Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and today I want to once again go over a very important concept which has baffled the mainstream math and calculus academics since the time of Isaac Newton. So let's begin. Now, you'll notice that throughout your calculus studies, even once you've finished a PhD, you still don't really understand calculus. You know how to apply it, you can solve differential equations, you can solve boundary value problems, you can do a lot of things, okay? But do you really understand what you're doing? Actually, no, you don't. And there are many reasons for it. And I've written hundreds of articles outlining these reasons. But today, I'm going to give you the most important reason, right, that has baffled mainstream academics since the time of Isaac Newton. And Isaac Newton and Leibniz are included. They didn't understand why their methods worked. Okay. So these two articles, Mainstream Mathematics Academics and the conclusion, are going to be placed in the details section so that you can study them on yourself. And for more information, you can go to my Academia.edu site and find hundreds of articles. Okay, interesting, that will educate you, lift the scales off your eyes, and teach you all the things that you need to know in order to become an excellent mathematician. Okay, not a mythmatician like those guys. So let's begin. We know that fools normally, and let me write this down because you don't normally see this. We know that in any mainstream textbook, which are worthless, but they cost hundreds of dollars, and other resources, you'll see something like this. Okay, so we can know fools by what they write down or what they say or how they communicate their ideas. So the fools of mainstream math academia didn't understand these things, because if they didn't, they'd never write down something like this. Okay, never. Why wouldn't they write down something like this? Let me explain. If this is supposed to relate the derivative, okay, I don't know why it's not switching to that color there. It should. That's strange. Okay, relate the derivative, which is this. I'm sorry, they don't actually write it like that. They write it like like this. Okay, but if this is supposed to relate the derivative to the integral f, then why not make it clear? Why not write it like this? Why not write it like this? F of b minus f of a is equal to that. Okay, because they didn't understand the mean value theorem. But I'll get back to that in a moment. So some mainstream math or calculus moron might retort that the theorem has two parts. Okay, one emphasizing the definite integral, and uh, the area. Okay, so definite integral as in you find an antecedent function, and the other is the area. So they do not know that this fundamental theorem, the so-called fundamental theorem, this theorem here, they don't know that this cannot be used unless both f and f prime are known. Okay, cannot be used. So numeric integration nullifies this entire thing. You can't use this. You can't use this. You cannot use this unless you know both of these. Okay. This is the so-called FTC written mainstream way. This is written the way of understanding, which the great John Gabriel, revealed to you, and you'll see in a moment why. So it involves not finding sum of infinitely many rectangles under a curve. This is just absolute rubbish. This is the rubbish that you were that you inherited from fools like Riemann and all the others. It doesn't mean that at all. Okay, and rather it involves finding the product of an arithmetic mean. Okay, two arithmetic means. So one of the arithmetic means is going to be that of all the y ordinates, and the other one is going to be that of all the x ordinates, and it's just simply the interval width. So it's simply the interval width times the arithmetic mean of all the y coordinates. Okay, and we can see that this comes directly from the mean value theorem, which I'll show you in a moment. But when one fails to understand, which means the morons of the last 500 years, all sorts of gibberish expressions arise. Things like average rate of change, which really just mean, I should have written it like that. Average rate of change, which just means the slope of that secant line, okay? And instantaneous rate of change, which just means the slope of the tangent line at that point, etc. Okay? So they resort to using words such as clearly and other expressions which clearly indicate that they don't understand. Okay? And mainstream morons use these words often. So what is behind all of this? Well, let's see. Let's just erase this for a second. Okay. So what really then is the fundamental theorem of calculus, and how do we get it? Well, it comes from the mean value theorem. So when you write, get that out of the way. When you write something like f of c is equal to f of x plus h minus f of x over h, this is the mean value theorem, okay? And what it says is that this here is the arithmetic mean of all the y coordinates. And it lives at some point c in this interval, x and x plus h. That's all it means. Thus, to find the area, which I've shown you here, this integral, this guy here, to find the area, all we do is we take this value, which is arithmetic mean, and multiply it by that one. So we already have one of the arithmetic means, it's that one. And to get the area, we multiply by h. And guess what? It works for any x plus h. So if you simply multiply h by f prime of c, you're going to get the area under the curve between x and x plus h. Don't believe me, moron? Try it. Try it with any function you like. Doesn't matter if there's an inflection point in there even. Try it, you baboons. I do know better than you. I've been telling you this for years. You need to perk up and listen because I know better. And I'm trying to educate you, re-educate you. You've never been educated. Okay, so now every theorem, just about every theorem you have in calculus, is really just a variation of the mean value theorem. And I'm going to show you the correct statement of this, of the mean value theorem, because it's never been given to you correctly. Okay, so several years ago, I first tried to explain this to the pitiful sheep on sci.math. Actually, it's decades ago. First time was 2005. The fools include distinguished professor at MIT, Gilbert Strang, distinguished professor Jack Hazinger, who's an ex-Harvard alumnus, David Ulrich of Oklahoma State University, and all of their ignorant colleagues. Okay, so correctly stated, the remarkable statement of the mean value theorem says, given any smooth function f prime of x, it has to be smooth. And by the way, you don't have to mention continuous because smooth implies continuity. Okay, smoothness implies continuity. No need to mention continuous like you find on the moronic Wikipedia articles, Math Stack Exchange, Quora, and all that BS. It just has to be continuous. And if it's not, it just has to be smooth. And if it's not smooth, you can toss calculus out of the window, you morons. There's no such thing as trying to find area over piecewise functions with one rule, okay? Which means you cannot use the mean value theorem or the theorem, the fundamental theorem of calculus, unless you have a function that is smooth over the given interval. It's impossible. So what I'm telling you right now is the remarkable statement, which says that given any smooth function f prime of x, the arithmetic mean of all the y ordinates of f prime over this interval is given by the statement here, the mean value theorem identity, okay? Where C lies between B and A. And this is how the derivative should have been defined, not in terms of that bullshit that you've been taught for ages. This absolute trash. Let me just get rid of this. Not this garbage. Not this garbage. F prime of x equals to lim h to 0 of fx plus h minus f of x over h. This is nonsense, okay? This is just utter garbage. So what the mean value theorem tells you is that you can find the area and the arithmetic mean using this identity. So that such a C exists is an unremarkable property of smooth functions. Here it pops up again. If you do not have a smooth function, you cannot use the mean value theorem. There's only one f related to one f prime, you fucking baboons. That's why you can't use piece functions. Piecewise functions. Do you get it, morons? Because it means that you have to do it for each piecewise function smooth over different intervals. Baboons. Okay? So, pay attention. I provide a constructive proof of this using the flawed mainstream calculus in my free ebook on pages 101 to 105, and also using the rigorous new calculus. By the way, new calculus derivative and definite integral are defined in terms of the mean value theorem. So when you diss the new calculus, you stupids, you're dissing the mean value theorem. Do you understand that? See how stupid you are? Who's having the last laugh now? Yeah? Yep, you guess right. It's me. Okay, morons? Now, and I'm not speaking to my followers, by the way, I'm speaking to mainstream math professors who are the scum and the filth of the earth. And if you're a mainstream math professor, I don't care who you are, silence is not excused. You stand up and you back me up, you fucking idiot. You don't keep your mouth shut just because of your tenure. You speak up and you say that I'm right. Okay, now let's see the various forms of the mean value theorem. So the first fact that is not realized is that the fundamental theorem is derived in one step. And I showed you. All you do is you take the mean value theorem identity, okay, this guy here, and you multiply f prime of c by h, and you're done, okay? Next, we have the hilarious average value theorem. Now, the average value theorem is still the mean value theorem. And this article shows you how you can get to it using the mean value theorem. Okay, so I show you by just replacing certain functions with different ones that you're still using the mean value theorem. So this thing is not an average value theorem, it's still the mean value theorem, stupid. Okay, then there's the hilarious mean value theorem for integrals over here. Now, look at that carefully, folks. Isn't that just the mean value written differently? See how syphilitic your mainstream brains are? And how do we know? We just replace f prime of x with f of x and f prime of c with fc. And we get the mean value theorem for integrals. It's actually still the mean value theorem. Baboons. Okay, so the astute reader will realize that the average value theorem is just another version of the mean value theorem. Okay? Now, is this still running? I hope it is. Yes, it is. Very good. Now, I get worked up when I've gone over this so many times, and believe it or not, there are still some people who don't get it. Your mainstream calculus is flawed. The formulation of it is flawed. The results, they sort of work. Yeah, the formulation is wrong. Now, download or go to the site and study this article and also the conclusion. In the conclusion, I explain all these things to you without pulling any punches. Okay? I don't whitewash anything. I skewer your math and calculus lecturers, which is how it should be. So please read and study both these articles carefully. Your math future depends on it. If you're not already a subscriber, folks, please subscribe to my YouTube channel. I earn very little in retirement benefits. And in fact, I'm in the poverty bracket. I'm so low that I don't even have to submit tax forms. So please subscribe, click like, tell your friends about this. And if you really want to learn more information, you can join my members only for $4.99 a month. It's just a cup of coffee. That's all it is. And you'll be supporting me. So that's pretty much it, folks. I'm the great John Gabriel. Till next time, if there is a next time, goodbye.